Okay, girls, I want to give you a little help on how to do this sheet because I want you to do it carefully and with a certain approach. You're familiar with claim evidence reasoning. We're going to do some claim evidence reasoning on these different physics scenarios. We've got a ramp. It's got a certain distance d, supported by some books, and the ball rolls down the ramp, rolls off the table horizontally, and lands in the cup. I'm going to essentially give you the answer to this first one, just so you can get the sense of how to do these. We're asked if the angle of this ramp was increased and the ball was still placed in the top and then you rolled it down again, where would you put the cup? Would you leave it right where it was? Would you put the cup closer to the table, or would you put it further than the table? Most of you probably could tell, just being around 17, 18 years, that if this angle is increasing, this ball will be now placed at a greater height. It'll roll down, it'll be faster at the bottom, and then the cup would have to be, you'd actually check that it should be further from the table. Let me just get my pen over here. So it'd be further from the table. Now, how do you explain this with physics? Well, you're going to have to really be very thorough. You'd say with a greater angle, right? If the angle is greater, then the height would be greater. Now, let's talk some physics. With the height greater, then you'd start out with a greater potential energy. Then you'd have to mention the conservation of energy. Says if you've got a greater potential energy, at the bottom you'll have a greater kinetic energy, and of course a greater velocity. So you really have to be very thorough. You might have just said, well, if it's starting from a greater height, it's going to come off the table faster, and the cup will have to be placed further away. Look how much physics we have to add, though. If it's a greater height, we'll get more PE. And the conservation, now what's the principle? Why would we get more KE? You'd probably say because it's obvious you'd get more KE, but I need you to talk physics. The conservation of energy says that because the total energy at the top will increase, the total energy at the bottom will increase. You're going to get more kinetic energy at a greater velocity. And now, why would the cup be placed faster? You might stop there. Well, look. The horizontal distance that's traveled would be equal to the horizontal velocity multiplied by time. If you're increasing the horizontal velocity, of course you'll increase the horizontal distance. So you see that you can't just, you really have got to talk physics each and every step of the way. If something is obvious, even if something is obvious, you still have to lay it all out. So this is an example of how extensive your explanation will be. Again, if you increase the angle, you're going to increase the height, which means that it'll start out with a greater potential energy. And the conservation of energy, here's a physics principle, you're using scientific evidence and principles, would say that if you have more, the potential energy at the top will turn into all kinetic energy at the bottom. So increasing the PE will increase the KE. Increasing the kinetic energy will give us a greater velocity. A greater velocity the horizontal distance that the cup is in is directly related to the horizontal velocity. If that goes up, then the horizontal distance will go up. So you can see how I really want you to be really extensive with your explanation. Now, the second half is, what if you had a hollow sphere? And you did, under the original setup, would the cup have to be placed further? Well, let's do the physics. What does that mean? A hollow sphere means the moment of inertia would be greater than the solid sphere, and therefore it'd be more difficult to rotate. So you would get the hollow sphere would come to the bottom with a greater, actually smaller velocity, linear velocity, and therefore back to dx equals vx. A smaller linear velocity would mean that you have a smaller horizontal distance. So once again, you can't just, you've got to give me the physics. Hollow sphere has a greater moment of inertia, which means it's more difficult to rotate, which means that you could also say that since its rotational KE, would be greater, its translational KE would be smaller, so the V would go down, and since dx equals vx, the horizontal distance is directly related to the horizontal velocity. If your horizontal velocity goes down, you expect the dx to go down. So you can play that over again and again, and hopefully that helps. But that's how extensive you have to be when you answer these problems. All right, good luck. Do a good job.